Hello, everyone. My name is Glenn Becker, and I want to welcome you to this session of the SAS Global Forum. This session is entitled Making Tables Smaller and Faster Without Data Loss. I'm Glenn Becker. I work for USAA, and I've been optimizing SAS data footprints and runtime since the early 80s. My background is computer performance and capacity planning, and now I help analysts and modelers save space and time. We're going to be looking today at how you can save space with short numerics, what SAS can do to save space with SAS compression, operating system-based compression, how SAS views can save space and time, looking at short numerics and how they perform, including a surprising technique that can make SAS tables smaller and by making some variables larger. And then we'll look at various ways to zip SAS data to save even more space. First, short numerics. In SAS, all numeric variables are 8-byte double precision, floating point in memory. But when you write them in disk, SAS lets them be truncated to 3 to 8 bytes. Mainframe lets you go down to 2. Now, the largest consecutive integer you can store for each length is represented in these formulas. Basically, distributed has 11 bits of overhead and mainframe 8. The SAS doc says it's the largest integer short exactly. That's not right, but it's the largest consecutive integer. SAS does not warn you about variable truncation, so be careful. I've been burned before making a numeric variable too short and having some unacceptable precision loss. So let's look at how SAS does compression. There's two options: compress equals yes, which really means compress equals char, and compress equals binary. Compress equals yes changes 4 or more identical bytes to only 3, like varchar. It's commonly used to get rid of the trailing blanks in those long character fields, but you can use it productively with numeric variable data also. Now, the SAS compress equals binary feature is intended for sparse or repetitive numeric data because it doesn't just compress single bytes, it compresses repeating patterns. And I'll show you in a minute that for a table that's very sparse, it can get you better compression, 70% versus 34%, but you pay a performance price for it. It's slower. Now, another trick you can do is rather than use compress equals binary for a very sparse table, if your application allows it, you can change missing values to zeros, then use compress equals yes, and it's smaller and faster. And the reason is that in double precision floating point, a zero value is really 8 consecutive 0 bytes. So 10 of those in a row is 80 consecutive 0 bytes that compresses down to only 3. That's really, really good. It's fast, and it's extremely useful. One little warning: the new varchar data type that SAS introduced in SAS 9.4 is only varchar when you're using it inside of a data step. When you write that data to disk, it becomes old-fashioned fixed length character, and that compress equals yes to get rid of trailing blanks is important. So let's look at how we can compare compression types. Now, this is a SAS EG project, and it's shipped along with the proceedings, so you can look at it. At least the programs are. And libname and memname and tableis are just some utility macros I wrote. And size is a macro that will tell you the physical size of the most recently created SAS table. And that, since we're interested in physical size, that's important. Now, all the examples here use only either generated data or data that's shipped with SAS, so you can run this on your machine at home. I'm going to begin with a table with many zeros, 100 0 bytes, and we'll call it lots of zeros. So let's see what lots of zeros looks like. Lots of zeros with compress equals yes. Yeah, you'd expect it decreases the size by 96%, and the table is 31 megs. That's pretty good. All right. Now, let's make a table with lots of nulls and see how it compresses with compress equals yes, which is the same as compress equals char. And you can see that the reduction is only 34%, and the same table is 530 megs. Well, how can we improve on that? Well, let's try taking the same data and compressing it with compress equals binary rather than compress equals yes. And we see that the compression ratio fall is 69%, and the physical size falls from 531 megs down to 247. So yes, compress equals binary does help, but let's see what helps even more. I have this little macro repeat 100 that just does something 100 times, and 100 times for each of the variables. I'm going to say if the variable is missing, make it 0. And for academic honesty, if it was a 0, make it a .z, so I can tell the difference between zeros that got made that way and zeros that are naturals. And then I compress that, and wow, it comes down to 96%, and the size is that 31 megs again. Moral of story: if you have a very sparse table, compress equals binary is good, but changing nulls or missing values to zeros is far better. So that's a technique that we use in our shop, and I strongly recommend it. You can always create a view, and I call this lots of nulls restored, that puts things back like they were. All right, let's go back to the slideshow and see what's next. Now, in addition to compressing, you can save space and time by using SAS views. Well, what are views? Well, an SQL view is just a select statement that's merged into your stuff, just like databases do. But a data step view is a program that runs while the view is being read, and data step views are very powerful. A simple view can save you having to store copies of data, and it can improve performance because you're not writing and rereading data to and from disk. You can actually do derivations on the fly. And even if you have to pass data through 3 or 4 layers of views, my experience is they're cheap. Let's take a look at an example. All right. In this example, we have, I'm going to make a large data set using SAS help zip code. And suppose I want a copy, but every alternative city name and zip code, I want to be a separate row. And when we look at the output from that, zip codes is 4 million OBS, but after I do that expansion, it grows to 7 million. And again, this is code you can run on your copy because everybody has that sashelp.zip codes. Now, that table in its native form, wow, it's a full gig of data. It took 8 seconds to do that expansion, and it took 3 more seconds to do a proc means. Now back here, when I did that expansion, you notice I put all the code in this zip code city statements, and I did that so I could easily reproduce it. Down here, we have exactly the same code, except instead of making it a data set, I made it a view. See, it starts with a v /view equals, and notice it took no time at all because making a view is just compiling a program. Now I'm going to run proc means on it, and this does all the work that the original data step did that took 8 seconds, plus the proc means that took 2, and it does it all instead of back here 9 plus nearly 3 is nearly 12. It does it in just under 7. But does it get the same answer? Well, let's look. Yeah, those 2 proc meanses look pretty much the same. So the moral of story is, rather than doing a data step, if you have a bunch of transformations to do, you can do the same transformations in a view. Not only do you save time, but you save space, because you remember that big table was a full gig? The view doesn't take any space at all to store. You're reading the smaller table to begin with. Views are very, very, very powerful when it comes to saving space. Let's go on. The other thing that you can do is look at how short numerics perform. We talked earlier about what they are, but there's something you need to know about how they work. SAS physically arranges numeric variables in a different order than their logical order, or the var-num order you'd get if you did a proc contents. It puts all variables of length 8 first on double word alignment, then the 4s on single word alignment, and then the oddballs are last with no alignment. Here's a little performance secret. CPUs run faster with word aligned storage. So if you make a numeric variable length 4 or 8, the result runs faster than if you make it some other length. Let's look at an example. Here we have a quick little test. I have 100 variables of length 3, and I made it a view so you can just see how long it takes to read, and the same variables of length 4. All right, let's look and see. The 100 variables of length 3, the champion, required 3.4 seconds to read. But making those same 100 variables of length 4 took only 2.75 seconds. In other words, by making those 100 variables on word alignment, I saved time. So if you're building SAS tables that people have to read quickly, where CPU processing is critically important, making things length 4 rather than 3 can save you time, even though it costs you a little space. The same thing is true with making things length 8 instead of 6 or 7. The one other little thing I wanted to caution you is views truncate short numerics. Like you can see this 1, 2, 3, 4, 5, 6, 7. I read it back, created a view with that, read it back, and you can see that it came back wonky. So even though a view passes its data to its reader in memory, it still does the same short numeric truncation. Now, I'm going to show you something that is kind of exciting that I was very surprised at. You see here it says zero loading. You get the best compression if variables that are most likely to be 0 are bunched together. And the reason why, remember I said that 0 is a 8 binary 0. So if you have a whole bunch of zeros slammed together, they compress much better than any other kind of numeric data. Let's see an example of that. So we're going to demonstrate the zero loading here. And what I'm going to do is define 20 variables as 10 odd-even pairs. And we're going to begin with them initialized at 0. But then I'm going to make every odd variable a non-zero value. So let's see what the result is. Now, in these sizes, please pay no attention to the percent compression because they based on nominal size, and that's going to change when we mess around with the lengths. It's actual size that really matters. Well, if I have naive lengths, everything's length 3, the actual size is 57 megs. Okay. Challenger. Oh, I'm sorry, I messed up. With looking at the wrong place. With naive lengths, the actual size is 74 megs. Now, first Challenger. Let's reorder the variables to put all the 0 ones first. Remember, the even numbered variables are 0, the odd number ones aren't. So I'm going to reorder them by defining all the odd ones at first, then define all the even ones, and then read it. So it's the same data, just with the variables reordered. And sure enough, when I do, the size falls from 74 megs down to 57 megs. Okay, because putting all the zeros together really helps. But suppose I have an application where the order of variables matter. Remember, you can have a variable A and dash dash B to mean all variables that are defined in a certain order, A to B. And suppose your application can't tolerate reordering the variables. There's another trick you can do. And that is, I'm going to leave the variables in their original order, but I'm going to set all the even ones, remember those are the 0 ones, to length 4. So they were 3, I'm making them 4, so I'm making them bigger than they used to be. You'd think, well, making a variable bigger will make it take more space. Remember, the original naive data set, the naive vars length was length 74 megs. But by making the even numbered ones length 4, wow, look at that. It falls down to 57 megs, the same order as the size as the reordered one. Moral of story, by making all the variables that are 0 or likely to be 0 length 4, that physically puts them together, and the SAS compression compresses them better. So if your app can't tolerate reordering variables, but you have some variables that are likely to be 0 and some not, put the ones likely to be 0 physically together. Either make them all 4s or 8s and make everything else a different size, or vice versa, make them an odd size and make your variables that have data 4s and 8s. Whatever you want to do, because remember, the physical order of the data is the 8s are first, then the 4s, then the 3s, the odd ones last. So pick one of those 3 groups and slam your 0s into there, and you'll find that that makes the table smaller. All right. The last idea I want to present today is how to save even more space by using zip type tools. Now, a SAS table is physically memname.sas7bdat, where the mem name is the SAS member name in lowercase, and that's true in both Unix and Windows. If the table has an index, there's also a mem name SAS7bndx, and if it has extended attributes, there's a SAS7bxat. So if you compress the table, you need to take care of those too. On ZOS, the library must be HFS. Oops. Here's a problem. If you zip SAS tables, first, they kind of disappear. You can't see them in SAS Enterprise Guide. And to use the data in any way, you have to completely unzip it, even just to do a proc contents of it. That's kind of a bummer. What you'd really like is a way to store data and have it unzip itself on the fly as it reads it. Well, I wrote such a thing I call Zypper. And Zypper is a macro that will take a regular SAS data file and convert it to a Zypper view. And a Zypper view is 2 files, a SAS data view that users can read, and a gzip file under the covers that contains the real data. And I'm not going to go through it all. I'm just going to say that under the covers, when a user reads the view, what he's really getting is it unzips the data on the fly. Rather than go through the macro, let's look at the results of what it takes to run it. So say Big Shoes is SAS help.shoes, everybody's favorite file, with every row repeated 100 times. I Zypper it, and then just to make sure it zippers correctly, I proc compare it. Then let's look at the size of the 2 results. See what we get there. Okay, so here's Big Shoes and the Zypper of Big Shoes and a proc compare. And the repair, it says the repair return code is 4. In my comment, it was 5, which means the only difference is that there's no in formats in the result. But let's compare the size. Big Shoes, even with compress equals yes, is 3.5 megs. But look at the size of the 2 files that Zypper created. Yes, I had to cheat and use an ls command so sorry guys. The view is about 139K and the data is about the same size. So the total of that is about 270 kilobytes rather than 3.5 megabytes. I'd say that's a big savings. So Zypper is really nice for data that you're not going to read very often. However, of course, you do pay a performance cost for it. Well, that's all the material I have today. Thank you, and I'll be happy to take questions.